Hey, good morning, everybody. This is Mr. Aynesworth. I want to get into stretching and compressing sine and cosine waves. So here we go. First thing I want you to do, though, is go grab your unit circle and your masteries and put them side by side in your lesson. So what we're going to do is we're going to go into Canvas real quick and do that. Just show you how to do that, and you can do that on your own. So let's go ahead and find those resources here. So in your Canvas here, go into Unit 1, or Mastery 1 on the unit circle here. And then, of course, open up my solutions right there. And you'll see a fully drawn out unit circle. So screenshot this and bring it in. And do that for Masteries 2 and 3 as well. Each one has instructor's notes, so open them up, screenshot it, and bring it in. Okay? And of course, go into the digital resources here and grab this file for today. All right, so let's get started. Here we go. What we want to do is read the goals first. So let's check this out. We want to understand how to stretch and shrink sine and cosine waves of the form y equals a sine of bx and then y equals a cosine of bx, both vertically and horizontally. Part 1 is we're going to take a look at the vertical change, and then part 2, the horizontal change. So I'm going to break up this unit here, this big lesson, and it's big, in 2 parts, okay? And so I can make the videos a little bit smaller and more digestible. All right, so vertical change is part 1. We're going to figure out the changes or the effects of A. To see the effects, we're going to change the values of A while keeping B equals 1, okay? So here we go. So again, when A, we're going to change A. We're going to notice that A equals 1 first, then A equals 3, and then A equals 1/2. But B, the coefficient of X here, is equal to 1. All right, so here we go. The first thing we do is we graph the parent function first. And by the way, that was a mastery here. See, we did that in mastery number 2. So you should be good with graphing sine and cosine easily. And remember, minimum 5 points. All right, so let's graph the parent function first, sine of X. And then we're going to change A and figure out what it does to the function. All right, so here we go. I'm going to label the y-axis first. 1, 2, and 3 right here. So go ahead and label. Okay, on this one here, we're going to go out, count out 8 units. 1, 2, 4, 6, and an 8 right here, and label that 2 pi. Okay, half of 2 pi is a pi. Half of pi is pi halves. So 1/2 pi, 2/2 pi, 3/2 pi. Okay, this is part of the mastery, so you should be good at this. And we're going to be plotting 5 points. And we're going to do this by evaluating the function. Okay, so here we go. All right, so y, when you substitute 0 in, the sine of 0 is a 0. So it starts at the origin. Okay, you guys know that. Sine of pi halves, well, guess what? You're at top of the unit circle, and the y-coordinate's 1 there. So pi halves comma 1. And then a sine of pi, well, guess what? That's back to 0. And then sine of 3/2 pi, well, guess what? That is -1. You're at the bottom of the unit circle. Oops, missed that right there. There we go. And then back all the way a full revolution here, sine of 2 pi, and that's 0. Okay, you have to be good at evaluating your points or the function at different points. Okay, so there is a sine of X. Okay, that's purple in a diagram. Okay. And notice that, by the way, that's mastery number 3. So if you look at mastery number 3, okay, you have to evaluate sine and cosine at different points around the unit circle here, and you have to do that using just triangles, okay, and not the unit circle itself. You have to be able to visualize and rewrite things in terms of its reference angle, okay? And that's why I did those masteries last week here, because you got to get good, guys. When you graph a function, you have to be able to evaluate at many points. Now, to see what A does to the function here, how does it transform the parent function sine of X? Well, we're going to do it by points. We're going to substitute them in, see what we get, graph it, and then analyze. Okay, we need to analyze. All right, so I'm going to switch colors. Do this for the entire activities here. When you're drawing multiple graphs on one coordinate plane, differentiate them using colors. Okay, so this one's going to be in blue. So here we go. So I'm going to substitute 0 in. So 3 times the sine of 0. That's 3 times 0. And usually that's 0. Okay, so here we go. 3 times pi halves. Okay, let's plot that, by the way. So we're right here at the origin again. So this one starts through the origin as well. So 3 times the sine of pi halves. Well, let me see. That's 3 times the sine of pi halves. Sine of pi halves is at the top of the unit circle where it's 1. 3 times 1 is 3. So pi halves comma 3. So go right pi halves up 3, and you're way up here. Okay, then we take 3 times the sine of pi. Sine of pi is 0, so 3 times 0 is usually 0. So 3 pi comma 0, so you're back on the axis again. And then 3 times the sine of 3 halves pi. Again, we're evaluating the function at multiple points here. So 3 sine of 3 halves pi, that's -1. 3 times -1 is usually -3. Haha. So go right 3 halves pi and then down -3. Simple. Okay, and then take 3 times 2 pi all the way around. So y coordinate there is 0. So 3 times 0, that's 0. So 2 pi comma 0. So you're back on the axis again. So we want to graph these bad boys, or sketch the graph, excuse me. So we're going to go up. It's increasing. Isn't it? It's decreasing. Goes right through there. Down to the minimum -1 and then back up here. Okay, that's not perfectly sketched, but that's pretty close. So that is sine 3 times the sine. Sorry. Let's fix this. Okay, 3 times the sine of x in blue. Oh, look at that. It affected the maxes and the mins. Okay, we call that the amplitude. Okay, we'll refer to that here in a minute. All right, so what would the change a to 1/2, what would that do to the function? Okay, so change colors again. We're going to evaluate. Okay, so here we go. So 1/2 times the sine of 0. 1/2 times 0 is 0. And then 1/2 times the sine of pi halves. Sine of pi halves is 1, and 1/2 times 1 is 1/2. And then 1/2 times the sine of pi. Sine of pi is 0, so 1/2 times 0 is 0. And then 1/2 times the sine of 3 halves pi. Okay, now your bottom of the unit circle, the y coordinate is negative there, so -1. 1/2 times -1 is -1/2. And then 1/2 times the sine of 2 pi all the way around. And the y coordinate is 0 there, so 1/2 times 0 is 0. So let's plot. So 0 comma 0, it starts at the origin. Pi halves comma 1/2. Now you guys know why I went up 2 units for 1. Okay, so it's easier to graph. And then pi comma 0 back at the axis. 3 halves pi comma -1/2, so down 1 unit and then back here. So it goes up and then down to -1 and then back. So this 1 in green here is 1/2 times the sine of x. So they all have the same period. Okay, this a does not affect the period. Okay, so let's first note. So a does not affect the period. That's the first thing that you notice, okay? It affects what's called the amplitude. All right, a changes the amplitude or the max and min. So the value of a, all right, changes, all right, the amplitude. Amplitude, okay? Which I'm talking about the max and min. So this distance here. So the distance between the relative max and the wave axis right here. So this distance right here, okay, that is called the amplitude A. Okay, A for short, amplitude. Okay, so let's do a little summary here. So it says, conclusion, explain the effects of A in the function, A sine x, in respect to the parent function, y equals sine x. In other words, does it affect the amplitude, the period of both? Okay. Well, as I just said there, so the absolute value of A, because A could be negative, all right, which is called the amplitude, okay, affects only the max and min. So it affects only the max, how high it goes, and the min, okay, of the graph. Okay, and not the period. Okay, The period remains 2 pi. Okay, there we go. All right, and so what we want to just do is, again, you just plot a bunch of points. You change one variable while keeping the other one the same to find the effects, and you just put in your basic skills, like graphing sine and cosine, for example, and also evaluating a function at a bunch of points. All right, now let's take a look at cosine. Does the same thing happen to cosine? Well, what do we do? Well, we plot a bunch of points, we graph 3 functions, we change a while keeping b the same, and we find out. All right, so here we go again. We're going to keep a equals 1, or actually graph the parent. So this is the parent function here in purple. Okay, and so here we go. So cosine of 0, guess what? That's the x-coordinate there is 1, so 0, 1. And we're going to graph this. Well, guess what? We have to do this again. So here we go. So 1, 2, and 3 again. You have to label the axes. Without that done, you're not going to get graded very highly at all, because without them labeled, you don't know what's going on, right? So always graph both axes. That shows me that you know what the angles are. Okay, these are called angles. All right, so here we go. So the cosine of pi halves, cosine of pi halves, you're at the top of the unit circle at 90 degrees. Guess what? The x-coordinate's 0 there. All right, then cosine of pi, you're halfway around. The x-coordinate is -1 there. And then the cosine 3/2 pi, you're bottom of the unit circle, and the cosine value is 0 there because the x-coordinate is 0 there. All right, and all the way around, cosine of 2 pi, you're back at 1. All right, so here we go. We start on the x-axis, or excuse me, the y-intercept at 1, because 0, 1 is up 1. So it's different than the sine function. And then pi halves come as 0, pi comma -1, 3/2 pi comma 0, and then 2 pi comma 1. So it decreases from 0 to 2 pi, right there, and then it starts increasing from pi to 2 pi. All right, and that is cosine of x. This is your parent function. Now, when you change a to 4, okay, well, actually, I wanted to change it too, so fix that, sorry. Should be, look at it, it says y2 equals 2 cosine x. So a is 2 there. Sorry if there's a little typo. So fix that. Okay, and then you evaluate. So here we go. So 2 times the cosine of 0, that's 2 times 1. Okay, 2 times 1 is usually 2, right there. And then 2 times the cosine of pi halves. Cosine of pi halves is 0, so you have 2 times 0, which is usually 0. And then 2 times cosine of pi. Cosine of pi is -1, so we have 2 times -1, or a -2. And then we have 2 times cosine of 3/2 pi. That's at the bottom of the unit circle, and cosine's negative, or 0 there, so we have 2 times 0, which is 0. Last one, 2 times cosine of 2 pi. And that's going to be 1, so 2 times 1 is 2. Okay, and guess what? That should have been in a different color, so let me change it to a different color. Whoops, okay, so I said change things to different colors. Okay, so 0, 2 is up here. All right, 0, 2, pi halves comma 0, back in the axis, pi comma -2, and then 3/2 pi comma 0, and then 2 pi comma 2. All right. So look at that, it changes the amplitude. So if you change a to 2, it affects the amplitude, not the period, just like in sine. So it decreases and then increases. And so this is cosine, 2 cosine of x. So once again, it changes the amplitude, the max and the min. The amplitude is seen right here, okay? A equals 2, or it's seen right here on the max up here. So a equals 2. So it changes the amplitude, not the period. All right, last one. What happens when a is 1/4? Well, here we go again. So 1/4 times cosine of 0 is 1/4 times 1, right, which is 1/4. Then 1/4 times cosine of pi halves. So 1/4 times 0 is 0. And then 1/4 times cosine of pi That's 1/4 times -1. Okay, you're on the left side of the unit circle there, and you get -1/4. And then 1/4 times cosine of 3/2 pi. So it's 1/4 times 0. You're at the bottom of the unit circle, and that's 0. And 1/4 times cosine of 2 pi, you're all the way around. So that's going to be 1/4 times 1, which is usually 1/4. Okay, now let's graph. So 0, 1/4. Okay, so this is obviously it's a half of a half is a fourth, so you're down here. You're half of a half a unit. So that's there, and then you're back to the x-axis there, and then pi, -1/4, and then 3/2 pi, 0, back to the axis, and then 2 pi, 1/4. So this one, the max and mins are relatively small. So 1/4 times cosine of x. There we go. Once again, it affects the period. It affects the amplitude. So A, the reason why we call that A, one of them, okay, not the only reason, it's a good letter for the amplitude, right? Okay, so A is your amplitude. So let's summarize everything here. All right, so here we go. So the A value, okay, the absolute value of A, which is your amplitude here, all right, affects only the max and min, okay? The max and minimum, okay, of the graph, not the period. Okay, there we go. So the period of all of these is right here. It's from 0 to 2 pi. So let's label that. Period is 2 pi. Amplitude changes, but the period does not. Okay, and what happened to sine when we did our first discovery right here pretty much is the same as cosine. So AFX is the amplitude, the distance to the max above the wave axis, which, excuse me, happens to be the x-axis here. All right, it's called the wave axis. I didn't really talk about that yet. I'll get into that more later. Or what some people call that the midline or the wave axis right there, but it's the distance above that and the distance below that. There we go. And that is part one. So part one, we talked about vertical change here of the sine and cosine functions. And then in the next video, in part two, we'll talk about horizontal change, how we stretch it horizontally. All right, this is Mr. Aynesworth. I will see you in my next lesson here. See you in class, hopefully, too. All right, bye-bye.